As you are probably aware, chemicals can be categorized as acids or bases. Acids and bases are both excellent conductors of electricity. Remember that stronger bases or acids are also strong electrolytes. When learning about types of bonds, we learn that acids are covalent and bases are ionic. Remember that covalent is a bond between two nonmetals and ionic is a bond between a metal and a nonmetal. When acids and bases are mixed, a conjugate base and conjugate acid are usually created. Occasionally, both acid and base neutralize and the products are water and salt instead. Two acid-base theories are used to describe this reaction, Arrhenius and Bronsted-Lowry. According to the Arrhenius theory, an acid will produce a hydrogen ion and a base will produce a hydroxide ion. This theory worked well for most reactions, but issues arose with the base ammonia, which did not contain any hydroxide ions and thus could not donate one. The Bronsted-Lowry theory was created to fix this issue. According to this theory, an acid will donate a hydrogen and a base will accept it. This is relevant as acid or base strength is measured by the concentration of hydrogen or hydroxide ions present, pH or pOH respectively. Acids and bases can be categorized as strong or weak, but they are more accurately measured by their pH or pOH. Again, pH refers to the concentration of hydrogen and pOH refers to the concentration of hydroxide. This is what the pH and pOH scale looks like. Something that is very basic has a high pH and a very low pOH. Something that is very acidic has a very low pH and a high pOH. Things that are generally neutral, such as pure water, would be somewhere in the middle. There are multiple ways to calculate a solution's pH or pOH. Each of these ways depends on what information you are given. Let's say you are given a molarity value for an acid. Molarity, as we learned in another unit, can be thought of as the concentration within a solution. Molarity is expressed by the following equation and is represented by the capital letter M. M equals moles over liter. The molarity of an acid multiplied by the molarity of a base will always give you a constant. This constant is represented by Kw, or 1 times 10 to the negative 14th. It does not have a unit. Given this information, we can find missing values. If we are missing the molarity of the acid, for example, we know we have to solve for the hydrogen ion in brackets. In other words, just solve for X. Let's try a quick example. Find the hydrogen molarity for a solution having the following hydroxide value in molarity, 1 times 10 to the negative 13th. We are given the hydroxide molarity and asked to find the hydrogen molarity. We know that the hydroxide molarity is 1 times 10 to the negative 13th, and we know Kw, our constant. If we plug in X for the hydrogen molarity, then we can solve. From here it is just simple algebra. To solve we must isolate X by dividing both sides by 1 times 10 to the negative 13th. We should get 0.1. Add the proper unit for molarity and you're done.